break. Okay, so today I'm gonna talk a little bit about browser history stealing, and you might say, whoa, again, browser history stealing, this is so 1990s. And I agree, but it's still an issue. And I'm also gonna show how technologies that actually have been meant to protect us are actually giving away additional side channels that help in stealing the browser history. So, who am I? I'm a researcher at SBA Research. I also teach at the Technical University here in Vienna, and we also have a CTF team that in the last 10 years won the International Capture the Flag contest, the biggest academic Capture the Flag contest 2 times, and scored in top 10 every other time. So when I'm going to talk about traffic, the most serious thing that can happen to traffic is actually getting man in the middle. And there is a situation where every one of us is man in the middle several times a day, especially if you're a traveler. And the thing is, in public Wi-Fi hotspots. So we all know it's like the well in the village, especially when you're abroad. You don't want to put a lot of money into or spend a lot of money at mobile phone companies, so you choose to use public Wi-Fi hotspots to circumvent roaming charges. And we all know the game. You get to this well where you can have a sip of internet or two, and then you move on. But before that, you have this logo sponsor displayed to you. And the technology used for this is actually called, or the system is called captive portal. There are multiple ways how to implement this, but basically it means you make a connection to your hotspot, you fire up your browser, and the first URL that you're trying to visit gets redirected to this captive portal where you see the message, maybe you see a short clip or advertisement. You click on OK to acknowledge the terms and conditions, and then you get connected to the internet and you think you have now perfect line of sight to the internet. But basically it means that this is a man in the middle by design. So not only the first connection, of course, gets redirected, but how does it get redirected? Well, an entity inside the access point or at the router intercepts the traffic and spoofs a response from the legitimate website, but it contains an redirect or a command, or it contains just other content. And this is then delivered to your browser, and your browser reacts to this. This means that some people are already aware, yeah, well, we're getting man in the middle fast, so I use pretty short URLs even if I don't want to visit these sites, but just to get man in the middle faster, get past this everything, and then I can enjoy my internet or my encrypted internet. And the thing with, as I mentioned before, is the browser history stealing part. So you might say, well, this is so old. We had this back in 2000. The famous bug was the visited link color. So basically, the browser renders visited links in a different color than non-visited links. That eases the user's navigation through a website. And with JavaScript, and later on even without Java, it was found even without JavaScript, you can read out the rendered style and infer if someone already has visited, or a script can infer if someone visited a site before or not. And later it was shown that this is actually used by shady websites like porn websites to get to know which other websites you also visit. But then you can argue, well, what's with browser history stealing? I mean, they just get to know what I surf from time to time or regularly. And the thing is that this gives away quite a lot of information about you, like maybe which language you're speaking. Just imagine someone has Amazon GP in the history. That probably means that this person speaks Japanese and or is from Japan or is at least living there. Or sexual orientation based on blogs you visit, partnership status if you're visiting partnership websites, medical conditions, political campaigns, religious communities, and also it will give away maybe the employer you are working for if there is something like intranet.youremployer.com. And this, of course, can be used for multiple reasons. It can be used for plain advertising, monetizing this information, or it can be also used for market research. Imagine, I don't know, McDonald's trying to find out if you're also visiting Burger King or other competition. But it can be also used as a first step for reconnaissance. Try to think of CEO fraud, for example. So in this case, just by knowing that you are employed at someone gives away additional information who is a good target. So that the whole spear phishing thing runs into this. And the easiest way to find out the history on unencrypted connections, at least, is using cookies. So this is like the first slide I found that described cookies from 1996. And this means that it actually predates same origin policy. It actually breaks same origin policy. And back then, like the only keys that been used were the host and the path, and later on they also added the protocol as an extension. But this means that every time your browser sends a request to a website, regardless how this request is created, it will send the cookies with it, if it's in their cookie vault or cookie database, in the local one. And this is used also for cross-site request forgery, for example. So just to give a little bit more background, there are two kinds of cookies. There are session cookies, which are forgotten quite fast if you restart your browser or restart your system. And there are persistent cookies, which usually has an age or expiry date attached to it. And these are the ones that are used for tracking users across sessions and across reboots and everything. And this is, of course, very popular with all the advertising networks. You can imagine, but it's also very popular for store websites to re-identify users that are visiting again, getting additional information, background on what products the user is interested in, and so on. The whole retargeting thing that is currently going on the internet is based on these persistent cookies. And since the problem with the cookies that they break same origin policy, they also been used, apart from this, for several other attacks like cross-site request forgery, their main target, cross-site scripting. And the other problem in the beginning, at least, was that cookies could be set and read regardless of the protocol. So later we got an additional extension that allowed cookies to be just on secure connections. And browsers put in additional restrictions on when you can set secure cookies, for example. But let's go back to the cookie thing. How do we actually steal browser history based on cookies in, let's say, a man-in-the-middle scenario like we find in a public Wi-Fi hotspot? Just keep in mind, this is just an example scenario. It also works in invisible man-in-the-middle scenarios, of course. So what an attacker, or in a Wi-Fi hotspot or rogue Wi-Fi hotspot, think of all the possibilities how an additional hotspot can be made, or how someone can be tricked into using a specific hotspot. The first thing your browser does is sending a request to a browser, to a website, like take a short one, cnn.com, and this is intercepted by the Wi-Fi hotspot with the captive portal, and it will redirect you to the landing page of this hotspot. And then for the attack to work, so the browser gets this, requests this landing page, and in this landing page, a malicious Wi-Fi operator or any other man-in-the-middle attacker can insert thousands of, let's say, image tags, but there are plenty of ways to hide external references that are automatically loaded into this website, and say there are like for a.com and b.com, and then your browser on the other side will try to fetch all these images, supposedly images, and the attacker can easily distinguish these requests from other requests by attaching like a random string to it that's most likely will fail anyway if connected to the real website. So a simple filter for this random string is enough, and all these image requests from the browser will automatically contain all the cookies that the browser has in store for this site, including, of course, all the tracking cookies that are set for this domain. And this means that we can now draw a simple flowchart. So we generate thousands of image tags to thousands of websites. If there is a cookie included in this request, this means that the browser must have visited this website earlier on to acquire these cookies. Most likely these are configuration or session or tracking cookies from this website. There are, of course, the other possibility, okay, if there is no cookie attached to it, then the site has never been visited, or the website doesn't set cookies, for example. We actually later on, we looked at the Alexa top 200,000 websites and found out that the vast majority of websites actually uses persistent cookies, one sort or another. So you can argue, well, sure, cryptography will save us. We will just have to switch to HTTPS everywhere. And there is another thing, because users are often typing the shorter URL without the S, so they are by default connecting to the unsecure website and then are redirected to the secure website. So browser vendors and the V3C consortium came up with a solution called HSTS, HTTP Strict Transport Security, which should enforce usage of secure channels or SSL for HTTP by maintaining a local database that will automatically change all the requests or the unsecure requests to encrypted requests if the website is known for supporting HTTPS. So the client caches this, and the next time, the client caches this on the first visit, and the next time the user enters this URL, the user is automatically redirected to the secure website. But then we thought about this and said, well, wait, this is another side channel giving away browser history, because the user can only acquire these HSTS setting with visiting the website before. So this means if the user has a cached HSTS entry in the browser and being transparently redirected from an HTTP URL to an HTTPS URL, this means the user visited the website before. So we can, when we take back when we look back at the graph I showed you earlier, we can amend this by another branch and saying, okay, we produce all these thousands of HTTP URLs, and if the browser transparently changes this to an HTTPS request, so we don't know exactly what the user requested, but we probably know because we created all these links in there in the first place, then this means that the browser had this HSTS entry either cached or preloaded. There is a preload list of about 6,000 websites currently. Half of them are all the localized Google websites and its variants. So basically the list isn't very complete at the moment. And this we can, so if it's not on the HSTS preload list, we still can infer that the user is actually visiting this, or visited the website before. We again can infer, okay, this is part of the browser history, at least on the host level. So which users are affected? You can ask, well, everyone who uses standard browser to log into a captive portal. And this includes VPN users. I will show this on the next slide. So about 1.5 years for Android, and I think 2 years ago for iOS, for the mobile devices, they have been introduced a functionality that's called captive portal detector. So what they do is when you attach to a new Wi-Fi hotspot, these devices will try to find out if there is a captive portal and will show you a message that you need to log into this captive portal before you actually have internet connection. I will show later that this is actually very easy to trick because it's unsecured connections again. So again, even if mobile users have a little bit more protection by having this captive portal detector by default in their operating systems, it can be easily disabled and the user is again forced to use the default browser. And whenever the default browser is used, again, the default browser has access to the standard cookie jar or the cookie database and will deliver all the cookies in there to what the browser thinks appropriate website. So I said VPN users are also affected, even if you VPN all your traffic. So why is that? So let's look at a time chart. On the x-axis you have the time, and you had like one Wi-Fi connection with a VPN, and everything you served, everything you visited during the VPN connection again is added to your browser history. And then the Wi-Fi connection breaks, so you move place, and you attach to another Wi-Fi. Here, of course, first you have the auto configuration, DHCP, and so on. You're redirected to the captive portal. And in this phase, your browser history is unprotected. And the captive portal can use the technique I described before to download the browsing history, even for the sites you visited during the VPN. So even if you then finish the captive portal, switch to VPN, the browser history up to this moment has been siphoned by the captive portal. So I'm going a little bit fast, actually. As I said before, there is a captive portal detection. It has been here in the default browsers for since a few versions of the operating system. And the thing with this captive portal detection is that it's a very simple one. So they have a finite number of test URLs that the captive portal detector requests in the background, and if these are redirected, then it assumes that there is a captive portal and needs some kind of login. You can easily find the list of it. Google has just a handful of test URLs. Apple has something like 2 or 3 dozens, but they are all finite and easy to spot. And if for a malicious Wi-Fi hotspot operator, they can easily hard code these URLs and whitelist them. So then the user gets no message, fires off the default browser to access the internet, and at this moment, again, the browser history can be stolen by the malicious access point. So this is something probably we will have to change in the future. The other question you might ask is, okay, for which websites I can actually steal the history? I mean, not all websites actually use persistent cookies or use HSTS. So we tried to find out more about this. What we actually did was we used, oh yes, and there is another problem with cookies. There are a few ways to set cookies. These cookies can be set either in the HTTP header, or they can be set dynamically by JavaScript. So how can we assess the World Wide Web? Well, I'm not very fan of the Alexa list, but at least it gives a little bit of insight into what websites are often used. So, and there are almost no other sources. The Alexa web, the ranking isn't the best one, but it's the best that is publicly available. So what we did is we rented a few Amazon instances and crawled with a headless browser, crawled that Alexa top 200,000 web pages and looked for the signs. Did they, after the initial request and send it and randomly clicking on free sub pages, do they start using cookies, and are these persistent cookies? And we also looked at the fact if they used HSTS headers or not. And probably not very surprising, we found out that for the top 1,000 websites, up to 92% of the websites use persistent cookies or HSTS. We have an upper and a layer bound here, and this is because with JavaScript cookies, there's no easy way to find out if they are persistent or not. So we can spot them, and most likely they are persistent, but we are not sure, so that's why we have this upper and the lower bound in here. For the top 200,000 websites, we estimate up to 86% of the website's history can be stolen from a user's browser history. So this is an estimate. There's still a few gray areas, like if there is a website that uses cookies for things like configuration, meaning you can change the font size, for example, for elderly people. So this might have not been triggered by our automatic bot, but this gives you a rough figure how many websites can be stolen from users' browser history. And we also implemented this and tested this with several dozens of people. So we have set up an access point, and what we actually found out that the fastest way for implementing this attack is using fake image tags. You can think of like JSON attacks, JSON requests or XML requests, but image requests are actually by far the fastest one. And you can also kill these connections so we started like with actually delivering one by one pixel images, but later found the browser starts requesting these images at a higher pace if we don't return an image, maybe just give an error code or terminate the connection, because then one of the threat workers from the browser is freed faster and can request the second one. So for like a mobile device, you can probe up to 100 sites per second on an average device. We also found out that these tracking URLs are easily connectable with other information. So for example, Amazon has this weird login system where you have a non-logged-in state, and half logged-in state, and a full login state. And this means that even if, and this half logged-in state tracking cookie is actually transported via HTTP and not an HTTPS only cookie. And this, so in this half login state, you can spot this with Amazon by, like, when you're adding something to the shopping cart, you can add things to your personal shopping cart, but at the moment you're trying to get some personal information or actually buy them, it will tell you that you need to log in again, although it already greeted you with your first name on the starting page. And this URL is an HTTP cookie and unprotected. And there is a little known feature that is by default on for all Amazon users, and that's the wishlist feature. And every Amazon user has actually a public wishlist, and the public wishlist gives away your full name. So using this unprotected tracking cookie, making a request with this cookie to this wishlist will make Amazon believe that you're that person and will show you the full name. So you can enrich this information that you collected on the web and enrich this with more deep information about the actual user that is currently surfing in this environment. Additionally, I didn't mention this before, during this non-VPN period or non-HTTPS period, your browser is also vulnerable to all the other attacks that are currently out there, like the web view attacks on iOS and Android. The main, yes, and I mentioned before, we get around 100 probes per second. So within 10 seconds, we have like the Alexa top 1,000 websites. However, the limiting factor we found out were actually the DNS round trips, because for every request the browser is requesting, there is an additional DNS request. So we could probably speed up this attack by having a good cookie DNS cache implemented. So what can we do actually against these kind of attacks? What can the industry do? What can one personally do? And there are like three main things. First, we have to look at the transmission of browsers. We have to look at the hotspot ecosystem as one point which has this man-in-the-middling technique by design. The transmission thing will hopefully kill all other man-in-the-middle cases. And then we can look a little bit at personal protection, what one person can do. So the first thing is we need to fix the hotspot ecosystem, because they're forcing us to uncover or to lower the covers that we usually have from our VPN sessions for this short period of time of the captive portal and the landing page. The problem with these landing page redirection techniques is they either have to intercept and change our unencrypted traffic, or sometimes they even try to spoof SSL certificates, which doesn't work that well in modern browsers, because self-signed certificates are no warning reason anymore, but they're actually an error message, a fatal error message. So we need some kind of new technique for giving hotspot operators a way to announce like the terms and conditions and maybe even their advertisements, but at the same time protect our browsers from using unencrypted traffic ever again. So For the mobile operating systems, we can think of having a better protection or a better detection of captive portals, and use something like a private mode for all the other connections, for example. Google came up with the idea of same-site cookies. It's mostly targeted towards cross-site request forgery and cross-site scripting. But for this kind of attack, this would mean that we need just one more step of indirection, because same-site cookies means the browser will only use these cookies if the request was produced by the same site that the cookies are for. But this can be easily circumvented with another redirection step, because the man-in-the-middle attacker or the captive portal can simulate any domain as long as it's unencrypted. There was an initiative for Hotspot 2.0, which is not widely supported currently, and its main target, was this the sign? 15 minutes, okay. Including discussion, okay. So this was actually meant for seamless roaming through different hotspots and not for getting rid of captive portals or redirection at man-in-the-middle. The other thing that helps is that, for example, Google is moving more and more APIs to HTTPS only. Recently, I think during the last year, they moved things like the location API to be HTTPS only. So this means that a malicious attacker can, for example, not request your actual position over an unencrypted website anymore. So sealing this one off, every time they do this, they break some parts of the internet, even if they announce this years beforehand. Just think of getting rid of MD5 and now SHA-1 signatures on certificates, for example, which has been also postponed several times. And maybe at one day we will come to a state where there are no cookies for unencrypted websites, for example. What can you do as a personal countermeasure? Well, use the private mode for surfing on unencrypted connections, and having a fresh history every time, especially when you're connecting to public Wi-Fi hotspots, and then fire your real browser only in the VPN connection, fire off. This means also like all the other authentication methods that are currently for Wi-Fi hotspot, but you probably will not find these in public Wi-Fi hotspots. If you're abroad, maybe bring your own hotspot using a local SIM card and a Wi-Fi router or something like this. So for conclusion, a lot of websites are vulnerable to this attack. They can actually, a man-in-the-middle attacker can actually find out if a user visited one or more of these websites quite fast and quite easily. It works in every man-in-the-middle connection, but we've chosen the Wi-Fi scenario as a hands-on example because this is like what everyone else is man-in-the-middle several times a day. There are side channels using cookies, which are a little bit unsurprisingly, but there are side channels introduced by technologies that should have made us safer, like HSTS. So this is my short conclusion, and we have like 10 minutes for questions. Thank you very much.
Hi. You mentioned quickly the HSTS preload list. And I was a bit disappointed that you didn't go deeper on that because this basically solves all your problems. Because then you're kind of closing down the HSTS leak and you're also closing down all cookie leaks because HSTS automatically makes all cookies secure. So we should use this preload list more. And at some point it will maybe stop scaling, but right now like everyone can submit their web page to it, and yeah.
Yeah, so I agree there should be far more websites on the HSTS preload list. This will make the attack described before much less effective and put holes into your browsing history. The thing is, running a professional so for professional websites, that could be an easy task. This should be like on a checklist for every new website that is going online. For many legacy websites or for many admins that do not care, they probably will not be added on this HSTS list anyway. But yes, we should use them far more. So apart from Google, there are currently about 3,000 other websites on this list.
Thank you for this very interesting talk. But did I get it right? As a personal countermeasure, I could easily, and I propose this a lot, use different browsers, and in particular use a one-shot browser to establish all my connections, and maybe in a container or something like this. This would also prevent this attack, does it?
Yes, so as I said, or use the privacy mode of your browser of choice. I would
suggest more to use a separated browser for that.
Yeah, so this is something I use personally as well. I use different browsers for different tasks, so that I know that if something happens to one browser, I can at least separate these different tasks. So like doing financial things with one browser and surfing blogs and Reddit or whatever else you do for entertainment with another browser.
I was asking this because to propose this even to not computer-affine people would help a lot.
Yes, we can also think of an extension of the privacy mode, like having these privacy slots in every browser that gives you multiple user or virtual users in the same browser that have different settings, different cookie jars, different ad blockers or whatever.
I don't think it really helps a whole lot to log into the captive portal with a different browser, because all the attacks you can do with the captive portal you can also do by injecting the code into some random HTTP web page.
Yes, so this is the solution for if you're a VPN user, for example. You use VPN all the time.
Yeah.
Yeah, so I was assuming this. So you use VPN for all your other traffic, but during the period of the captive portal, you have to use unencrypted traffic, yeah. One in the front.
Regarding the Google preload list, what's the criteria of getting on that list?
Oh, good question. Hannah knows the answer back there.
You just need to set an additional flag preload in your header, and then you sign up on some web page. It's super.
The question was from Google.
Yeah.
Yeah. So the Google list, the Chromium list is public, and they are automatically integrated by all the other big browser vendors.
Will that scale? I mean, this is
the HSTS list. Well,
preload list. I mean, if every second web page in the world wants to be on that list, how big
yes.
will the download be? I mean,
so
this is not sustainable.
We can probably solve this for the Alexa top 1,000 pages or top 5,000 pages easily. At some point, it will not scale. So at some point, the only solution that I see is having SSL by default.
That, or use Dane for that.
Or what?
Use Dane.
Yeah, maybe.
Hi, thank you for the nice talk. Just a quick question, will you release the proof of concept code to show it to others?
Yeah, I mean, it's quite ugly VM, but using an USB Wi-Fi stick for simulating the hotspot. Basically, I'm not very good at Ruby, but it would make it perfectly fit into BetterCat, for example. So maybe someone likes to port this there.
Okay, thank you.
Yeah, but write me an email if you like to have the VM.
No, I don't know. Oh, yeah. Hello. I don't know if that is known or easily knowable, but do you maybe have any idea, any data about how many legitimate websites do stuff like having thousands and thousands of tags that contain a source attribute and
So
could be detected by the browser?
So for the old browser history stealing techniques, there have been papers researching this, and they found out that for example, porn websites like to use this. But for this Wi-Fi stealing method, we don't know. It's also hard to assess because you need someone to go around all the hotspots. Although we have currently a project that I hope to get running by mid of next year to do these hotspot assessments using an app that is installed on a phone, and that people can install and then be like drones and making honey traffic on every hotspot to see if it gets intercepted, if users, if the credentials are then reused in other places and stuff like this.
Thanks.
More questions? We've got a lot of time still left, 5 minutes or so.
Thanks for the talk. Could public key pinning also be used, like HSTS, to identify websites that have already been visited?
The public key pinning, the key pinning or the certificate pinning is a thing that will show an error message in the user for the user. So maybe you can use this in a scenario where like you have an on-error loader, error event handler attached to this image, but I haven't tried this out.